Greetings of the day. Hi, this is Vidya. Welcome to my channel, AI. Wondering about what asymptotic analysis is? Well, in this session, we are going to discuss about asymptotic algorithmic analysis that impact the performance of the application. This is a very vital topic for computer programmers. Asymptotic analysis is a technique applied for design and analysis of algorithms. You would have probably quite often heard this from designers, architects, and programmers talk about. The performance of a program is system dependent and rely upon various factors, including compilers, compute capacity, the CPU architecture, programming languages used, interfaces, data structures that are applied, and so on. Now you will understand the basic factors that influence the performance of the program or an application. When we talk about performance of an application, there are two factors which need to be considered as environment in which it executes in addition to design and architecture. The two factors that can be considered are internal factors and external factors. Internal factors are ones that is affecting the performance that needs to be taken care when the application is designed. Some of the notable internal factors that needs to be taken care are the data structures that need to be used, the most efficient way of communication models across threads and processes, the amount of memory that needs to be allocated, the memory consumption of an application, the number of threads that needs to be created, and so on. External factors of an application performance include the system memory, the number of processors, CPUs, the types of IO input-output adapters, and so forth. These factors essentially determine the number of resources available for the application to utilize. It is actually the design which determines the minimum requirement of these external factors for an application to give the desired performance. So by definition, asymptotic analysis helps programmers to identify the spotlight by eliminating the constant and lower order terms. What it means is that if a program with n elements that's running in a factor of a quadratic equation as you see here is 3n squared plus 2n plus 6, then we say that the complexity is O of n squared. The lower order terms like 2n and the constant 6 can be considered to be ignored as it's relevant in most cases. Well, it essentially does not mean that the constant and the lower order values does not matter at all. However, ignoring those values shall help us grab a high-level impression on the performance of the algorithm and leverages an easy mechanism to compare the various solutions. On the other hand, if you were to consider the lower order values for complexities in one case, it is better recommended to use the same methodology across all algorithms for equal comparisons. Having said that, the asymptotic analysis is also referred to as BigO notation of time complexity for code under analysis. Hope this gives you a good understanding of asymptotic analysis. Thanks for watching.